right, we're going to begin a lecture on fractions. Fractions lecture is actually a 2-day lecture. So we'll start with one part of fractions today, and we'll continue with fractions tomorrow. So you will need this packet or the worksheets I will send over to you, and make sure to follow along with them when we're going over this. All right, so number 1 says, what is a fraction? Well, the fraction is going to be a part of a number. And then we have a denominator and a numerator. Okay, so if I have, that's going to give me a fraction, which is going to be a part of a number. Okay, we have a denominator, which will be the bottom number, and a numerator, which will be the top number. Okay, the denominator is going to represent a whole. The top number, the numerator, represents a part. Okay, and so I have all these little circles here. Okay, and they're all going to make a fractions. We like to use circles when we're referencing to fractions because of the fact that we can equally divide that in two parts. So, this whole pie right here, it has whole 2 pieces in it. So 2. This whole pie, 1, 2, 3, whole, has 3 pieces. This whole pie, 1, 2, 3, 4 pieces. 1, 2, 3, 4, 5 whole pieces. 1, 2, 3, 4, 5, 6 whole pieces. Okay, and that's how we get the denominator. How many pieces are in the whole entire pie? Now, to get the part, the top number, we can get the numerator by doing 2 different things. One is we can say how much is left over or how much is missing. So I love pie, so I'm going to eat some pie. I'm going to shade in some pie. Okay, how many pieces of this pie did I eat? Just one whole piece, like one part of it. 1 piece out of a 2-piece pie. Over here, I'm going to shade in 2 of them. Perfect. So I ate 2 pieces out of a 3-piece pie. So I ate 2 parts of it. Over here, okay, I ate 2 pieces out of a 4-piece pie. Over here, I ate 3 pieces out of a 5-piece pie. And then over here, I ate 3 pieces out of a 6-piece pie. And that is how you get a fraction. Okay, but I can't leave all these fractions like this because there's a hidden rule with all fractions, and that hidden rule is always reduce. I'm writing it in red. Anything in red is always going to be extremely important to remember, so always reduce, okay? Now, to figure out if we're going to reduce, knowing your prime numbers is going to be super beneficial to you. So a prime number is a number that only 1 in itself can be divided by. I'm going to attach a prime number grid, and I'll send that over to you to help you with your prime numbers as well. Okay, so we have to divide the fraction by the same thing. All of our prime numbers are odd numbers except for the number 2. The only thing that can go into a 2 is a 2 and a 1. All the other prime numbers are odd though. 3 is a prime number and is odd. 4 is even. Every even number can be divided by 2. Every even number can be divided by 2. So we're not going to worry about that. Okay. 5 is odd. It is also prime. 6 is odd. 6 is even, so 2's can go into 6. 7 is odd. 7 is prime. 8 is even. 9 is an odd number, but it is not a prime number. 9's can be divided by 3's. So that's an example that not all odd numbers are prime though. So I have a 1 and I have a 2. We know that, but both those are primes, so that one's done. I cannot do anything else with that one. Okay. I have a 2. Ooh, 2s can go into 2s, but 2 cannot evenly go into 3s, so that one's done as well. I have 2 even numbers. Remember, 2 can go into every even number. So I'm going to divide both these by 2. Oops, that doesn't work. Okay. 2 divided by 2 is 1. 4 divided by 2 is 2. I got a 1, I got a 2. That one's done now. 3. 3 is a prime number, so the only thing that can go into a 3 is 3. But 3 cannot evenly go into 5, so that one's done. 3 again is a prime number, so the only thing that can go into 3 is 3. But can 3 go into 6? Yes, so I'm going to divide both these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Perfect. And that is how we reduce. Continuing with our worksheet, we're going to continue down to reducing to the lowest. All right, we're going to look at number 1 is 2/14. Okay, these are both even numbers, so what can go into every even number? 2. Divide them by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. Next up is 3/27. We're going to have 3/27. 3 is a prime number and an odd number, so the only thing that can go into 3 is 3 by itself, so I'm going to divide them by 3s. 3 divided by 3 is 1. 27 divided by 3 is 9. Perfect. Okay, I want you to go ahead and look all the way down to number 5. Okay, number 5 is going to be 13 as a whole number over 2/8. Okay, we don't need to touch this 13. We still need it to be part of our answer, but we don't need to touch. Okay, so it still needs to be part of my answer, so I'm going to put it down here as part of my answer. We just need to reduce just the fraction part. They're both even, so 2s can go into every even number. 2 divided by 2, 8 divided by 2, and then I'll add that to my whole number. Okay, flipping the page over, we're going to go into changing improper fractions to a mixed number. So we have 15/2. Perfect. Okay, I want you to go to the word at the top where it says improper fractions, and I want you to draw a line through the word improper. Draw a line right through it. And I want you to put naughty above it. Perfect. Just like that. Okay, now when we are dealing with improper fractions, okay, what I want you to think about is if I want you to think about like a lacrosse game or a hockey game. Okay, when there is a naughty player in a hockey or lacrosse game, as a fan, you get to scream 4 words at this player. They are naughty, they are improper, and you get to scream 4 words at this player. Okay, those 4 words that we get to scream at them are get in the box. Okay, it flashes on the Jumbotron, you get in the box. What you scream at these naughty lacrosse or hockey players. Okay, this fraction right here, the top number is naughty. It's improper. We are not allowed to have a top-heavy fraction. So when we get a top-heavy fraction, I want you to scream, get in the box. It's naughty. Okay, so what box am I talking about? Division box. This is why I made you do long division, is so that way you would set you up to understanding improper fractions. So who's naughty? 15 or 2? 15. He can't be bigger than the bottom number, so he's naughty. So 15 needs to get in the box. Perfect. 2, he's our good player. He gets to sit outside the box. Nah, boo-boo. Okay, now we're going to divide now. So can 2 go into 15? Yes. How many times? 7. 7 times 2 is 14. Subtract, I get 1. Now earlier when we were doing whole numbers, that 1 became a remainder. It is still a remainder, it just comes up a little higher. Our denominator is still the same. Perfect. We're going to do another one. We're going to move on to number 2, which is 39 over 2. Okay, 39 is improper or naughty. So what should we tell 39 to do? Get in the box. Perfect. Okay, 39 is the naughty one. He goes in the box. 2 is the good one. He goes outside the box. Can 2 go into 3? Yes. How many times? 1 time. 1 times 2. Again, I'm only working with these ones. Subtract, I get 1. Bringing down my 9. 2 go into 19? Yes. 9 times 2, 18. Subtract, I get 1. That 1 is now my remainder, just up higher, numerator. 2 is still my denominator. Perfect. All right, moving on to the next section. It says changing the mixed numbers into improper fractions. We want to make them improper fractions. So number 1 is 1 and 1/2. So 1 and 1/2. Okay, just now when we were changing them into proper form, that denominator did not ever change. The only time that denominator changes is if I have to find a common denominator or if I'm reducing. But if I'm changing from improper to a mixed number to improper, it does not change. So automatically I know my denominator is going to be the same, 2, 2. Okay, we just have to focus on getting the top number. And to do that, I am going to take my denominator, multiply it by my whole number. So 2 times 1 is 2. Circular motion, add my numerator. So 2 times 1 is 2, plus 1 is 3. Perfect. Number 2 is 6 3/4. So 6 3/4. Automatically, I know that my denominator is going to be a 4. It stays the same. So 6 times 4, circular motion, adding the 3. So 4 times 6 is 24, plus 3, 27. Perfect. All right, next up are the equivalent fractions. So with equivalent fractions, what I want you to do is I want you to line these up differently. So I just want you to line them up. So they're going to be read the exact same, but we're just going to line them up. So we're going to do 5 over 7 equals x over 21. So let me do 5 over 7 equals x over 21. And it's just read like this on your sheet. Oops, maybe if I could write it better. That's how it's read on your sheet. I just lined them up this way instead. Now what I want you to do for this one is going to be cross multiply and then divide by your lonely number. Okay, so what we're going to do is we're going to find our 2 diagonal numbers. X is not a number, so those are not diagonal numbers. These ones are my diagonal numbers, so I'm going to circle them. Okay, cross. I'm going to multiply those numbers. Cross multiply would be 5 times 21, which is 105, Then I'm going to divide that by my lonely number over here. Divided by 7, and I get 15. Okay, number 2 is 9 over 30 equals 3 over x. So 9 over 30 equals 3 over x. Okay, x is not a number, so those are not my diagonal numbers. Diagonal numbers, cross, multiply. 3 times 30 is 90. Divided by my lonely number gives me 10. Perfect. All right, our last section on this is going to be the adding fractions. Okay. So when we're adding fractions, there are some rules I'm going to put on the board for you. Okay, when we're adding fractions, so adding and subtracting have the exact same rules. So when you're adding a fraction, there's a number one step. Number one step is we need a common denominator. Common denominator means we have to have the same number on the bottom. Okay? Do I have the same number on the bottom? I do not. Okay, so the easiest way to get the same number on the bottom and guarantee that we're going to have the same number on the bottom is to multiply the denominators by each other. Okay, so we're going to multiply bottoms by each other. Perfect. Okay, so 8 times 10 is 80. That's my new bottom number. Make sure not to switch the order when you're making a new problem, because when you get to subtraction, that will completely throw your answers off. So 80 is my new bottom number. Perfect. Now, the next step, okay, is whatever we did to the bottom number, I must do to the top number. So the 8 got multiplied by the 10, so must the 3. So I'm going to cross multiply the tops. The 10 got multiplied by the 8, so must the 7. So 3 times 10 is 30. 7 times 8 is 56. Next step is we are just going to add or subtract just the tops. Okay, 30 plus 56 is 86. The bottoms just slide over. I don't do anything with it, I just slide it over. Okay, now I have 86 over 80. But can I leave it like that? No, because in red, always reduce. And it's a top-heavy fraction. Oh no, so 86 must get in the box. Who's naughty? 86. 80 is my denominator. It's the good guy. Can 80 go into 86? Yes, one time. 80 times 1, 80, subtract, I get 6. 6 is my good number, goes to the top, over 80. Perfect. But this is still even, so I can still reduce it. So divide those by 2. 6 divided by 2 is 3. 80 divided by 2 is 40. So my total answer, don't forget your whole number, he's still part of the answer, is 1 over 3/40. All right, let's practice with another one. So number 3 is 3/10 over 6/7. So 3/10 plus 6/7. Okay, step number 1. Okay, same number on the bottom. Do I have the same number on the bottom? No. So we have to get the same number on the bottom. Easiest way to do that again, multiply the bottoms by each other. Perfect. Okay, so make a new problem. 10 times 7, 70. Okay, next step, cross multiply the tops, because whatever I did the bottom, I have to then do to the top. So 3 gets multiplied by the 7. 3 times 7, 21. 7 got multiplied by the 10, so must the 6. 6 times 10, 60. Next step, multiply or subtract tops only. Well, 21 plus 60 is 81. Next steps, the bottom just slides over. Okay, and as always, we always reduce. Top heavy fraction, so 81 needs to get in the box. Perfect. 81 is naughty, 81 goes in the box. 70 is my good number. He sits outside the box. Can 70 go into 81? Yes. How many times? 1. 1 times 70. Subtract. 11. 11 is now my numerator over 70. And I cannot reduce that, so that is your final answer. All right, I want you to continue working on this worksheet with the problems that we did not go over. Practice, 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 and then you can work on chapter fraction 1 homework, which will open in Blackboard. Tomorrow we will continue with fractions, so we are not finished with fractions by all means, and won't have a test tomorrow on either. So continue with this worksheet. If you have any problems or need any assistance, please feel free to contact me. Thank you.